Chapter 2, Section 4, Physics Talk, Newton's second law of motion. Newton's first law informs us what happens to objects if no net force acts upon them. Knowing that objects at rest have a tendency to remain at rest and that objects in motion will continue in motion does not provide enough information to analyze collisions. Newton's second law of motion allows you to make predictions about what happens when an unbalanced external force is applied to an object. If you were to place a collision cart on a level surface, it would not move. However, if you begin to push the cart, it will begin to move. Newton's second law of motion states, if a body is acted on by an unbalanced force, it will accelerate in the direction of the unbalanced force. The acceleration will be larger for smaller masses. The acceleration can be an increase in speed, a decrease in speed, or a change in direction. Newton's second law of motion indicates that the change in motion is determined by the net force acting on the object and the mass of the object itself. Physicists are never satisfied with a verbal explanation and always ask, is there an equation that can describe this precisely? Newton's second law does have such an equation that can be written as force equals mass times acceleration, or acceleration equals force divided by mass. From this equation, one can see that if a body is acted upon by an unbalanced force, it will accelerate in the direction of the unbalanced force. One can also see that the acceleration will be larger for smaller masses. What is whiplash? In the collision in the investigation you completed, where the target cart did not have a headrest, the clay head swung back during the collision. Whiplash is a serious injury that can be caused by a rear-end collision. The back of the automobile seat pushes forward on the torso of the driver, and the passengers and their bodies lunge forward. The head remains still for a very short time. The body moving forward and the head remaining still causes the head to snap backward. The neck muscles and bones of the vertebral column or spine become damaged. The same muscles must then snap the head back to its place atop the shoulders. This is a sprain or strain of cervical tissues. A headrest can prevent whiplash injury. The headrest must be adjusted for the height of the passenger. Newton's first and second laws of motion and whiplash. The activity in this section demonstrated the effects of a rear-end collision. Newton's first law and Newton's second law can help explain the whiplash injury that passengers suffer during this kind of collision. Imagine looking at the rear-end collision in slow motion. Think about all that happens. An automobile is stopped at a red light. This is the automobile in which the driver is going to receive a whiplash injury. It was the target cart in your investigation. The driver is at rest within the automobile. The stopped automobile gets hit from the rear. The automobile begins to move. The back of the seat pushes the driver forward, and the driver's torso moves with the automobile. The driver's head is not supported and tends to stay back where it is. The neck muscles hold the head to the torso as the body moves forward. The muscles then whip the head forward. The head keeps moving until it gets ahead of the torso. The neck muscles stop the head and pull it back to its usual position. Ouch. Let's repeat the description of the collision and insert all of the places where Newton's first law and Newton's second law apply in color. An automobile is stopped at a red light. This is the automobile in which the driver is going to receive a whiplash injury. The driver is at rest within the automobile. Newton's first law, an object at rest stays at rest, and an object in motion stays in motion unless acted upon by an unbalanced outside force. The stopped automobile gets hit from the rear. The automobile begins to move. Newton's second law. The automobile accelerates because of the unbalanced outside force from the rear. Force equals mass times acceleration. The back of the seat pushes the driver forward, and the driver's torso moves with the automobile. Newton's second law. The torso accelerates because of the unbalanced outside force from the back of the seat. Force equals mass times acceleration. The driver's head is not supported and stays back where it is. Newton's first law. An object, the driver's head, Newton's first law. An object, the driver's head, at rest stays at rest. The neck muscles hold the head to the body as the body moves forward. The muscles then whip the head forward. Newton's second law. The head accelerates because of the unbalanced force of the muscles. Force equals mass times acceleration. The head keeps moving until it gets ahead of the torso. Newton's first law. An object, the head, in motion stays in motion. The head is stopped by the neck muscles. The muscles pull the head back to its usual position. Newton's second law. The head accelerates or slows down because of the unbalanced force from the neck muscles. Force equals mass times acceleration. Ouch. Newton's second law informs you that all accelerations are caused by unbalanced outside forces. It does not say that all forces cause accelerations, only those that are unbalanced. An object at rest may have many forces acting upon it. When you hold a book in your hand, the book is at rest. There is a force of gravity pulling the book down. There's a force of your hand pushing the book up. These forces are equal and opposite. The net force on the book is zero because the two forces balance each other. There is no acceleration because there is no net force. As an automobile moves down the highway at constant speed, there are forces acting on the automobile, but there is no acceleration. No acceleration indicates that the net force must be zero. The force of the engine on the tires and road moving the automobile forward must be equal in magnitude and opposite in direction to the force of the air pushing backward on the automobile. These forces balance each other in this case, where the speed is not changing. There is no net force and there is no net acceleration. The automobile stays in motion at a constant speed. A similar situation occurs when you push a book across a table at constant speed. The push is to the right and the friction is to the left, causing opposing motion. If the forces are equal in size, there is no net force on the book. The book does not accelerate, it moves with a constant speed.